So in this class we will discuss about how the nanotechnology is so cool, or how why the nanotechnology is getting so hype, or all those things. So the reason is this, that we have already discussed in the previous class. This is where it starts. It was a continuous topic to the background of this thing. So I will explain this. I will just mention out things that are naturally available and things that are man-made. We know that from ant, which is 5 millimeter. Here we are having man-made things which is head up between 1 to 5 millimeter. Goes with the 5 ash, 10 to the 20 micrometers. Same thing goes for MEMS, which is being done. And then RBC, which is important for our to transfer oxygen inside our body, is equal to almost, we are having the again MEMS. Then we are having the ATP this, the diameter is around 10 nanometer. We can compare that with our zone plate X-ray lenses, which gets outer ring spacing is around 35 nanometer, and diameter of DNA is 2.5 nanometer, and that we can compare with the carbon nanotubes. And I explained you why the carbon nanotubes are so important. And then finally we are having the atoms of silica, which is spacing around 0.078 nanometer. That is also we are having quantum coral, so of 48 iron atoms on copper surface, positioned one atom at a time with the help of scanning tunnel microscope tape. So that was around 14 nanometer. So that's how all these things comes, and credit is given here, Office of Basic Energy Sources, okay, from US. So the nanobottle, I will just tell you why these particular nanomaterials are getting so hype, and what is it that the nanomaterials are so different from the natural materials or bulk materials. And we will just see why nano is so fascinating, why nano is so cool. So strange thing happens at a small scale. Okay, I will discuss in the introduction. So if you keep cutting until the gold pieces are at the nanoscale range, they don't look like gold anymore. They look red in color. Can you imagine? So in fact, depending on the size, they can turn red, blue, yellow, and other colors also. For example, we are having the 12 nanometer gold particles which look red in color, right? Others is also other colors. So different colors, we are having different things. At around 100 nanometer purple, it is giving at around 80 nanometers or 50 nanometers, is giving deep purple in color, then pinkish and little bit pink, and then finally red in color. Why all these things are different? What is the reason? So the different thickness of the materials reflect and absorb light differently. It's as simple as that. Have you studied the UV spectrophotometer? If you have studied it, or if you have used it, you will be knowing that the amount of the light, whatever it is absorbing, whatever the sample is there, the UV spectrophotometer, those who don't know, I will just explain you. In UV spectrophotometer, it was based on the light absorption. So if you keep the sample inside the UV spectrophotometer, the light will come and hit onto this particular the sample, and it will pass through. And when it is passing through, it depends on this how much light is absorbed. Some of the materials will be there. For example, if the material is at 100 nanometer, absorbs light at different wavelength. If it is around 80 nanometer, it also absorbs a different wavelength. Then if it is 20, then it totally different nanometer. So that means the different particle size are absorbing different lights. So definitely they are giving you different color. As simple as that, right? So simple physics here, right? So that's how it works. Okay, so why is nanotechnology so cool? Again, the same thing. You take a bulk gold, which is golden color or yellowish in color. Melting point is around 1164 degrees Celsius. The color is gold, or I can say yellow. The 1 nanometer gold particle is around something looks like almost gold in color, yellow in color, brownish yellow in color. The melting point changes from 1064 degree to the 700 degrees Celsius. The lambda mass, that is it absorbs the maximum wavelength at 420 nanometer. Okay, and the color will be brownish yellow in color. But if you speak about just changing in the nanoscale only, I am changing from 1 nanometer to the 20 nanometer. Okay, so that means every particle size is 20 nanometer. So every particle, gold nanoparticle size, when it becomes 20 nanometer, then we are having change. There is a huge change from melting point. So here it was went around 700 degrees Celsius to nearly 1000 degrees Celsius. Lambda max changes from almost 100 nanometer difference. That's why the color is different from brown yellow to the red in color. Next color changes to the red in color. So speaking about 100 nanometer gold particles, we are having melting point around again same thing, which is nearly 1000 degrees Celsius. There is no much change from 20 to the 100 nanometer, because as it is go on increasing to the molecular size, there might not be much difference, but as it is moving to the atomic scale or near to the atomic scale, there will be huge difference. So as we know, at atomic scale, the science is totally different. And here there is a slight change in the nanomax, that is 521 nanometer to the 575 nanometer, and the color also changes, purple pink in color, different. Why? Because of the different wavelength. That means lambda max, that means the maximum light which is absorbed by the 100 nanometer particles are at 575 nanometer, whereas 20 nanometer samples will absorb at 521 nanometer, the maximum wavelength. That's why they look different in color. So we can have different colors. And what is the difference here, and why we need these different colors? What is so cool about it? It's very important when it comes to the optical properties, okay, of the any particles. We can use it for our drug delivery systems, and also to track down the tumors which are present in our body. And also we can use it as instead of radioisotopes, we can use the nanoparticles to load the drugs and send. And then finally, with the help of the light color in different colors, we can identify the inside the body where exactly the tumor is there, all those things. So that's why it is so cool. And there is one more example I would like to give why nanotechnology is so much cool. Okay, so you take for example one box whose diameter is around 6 centimeters square. That means every face is just diameter is around or the area is around 1 meter square. 1 meter square box is, in a sense, since the box has got its 6 faces. So 1 meter square into 6, so 6 centimeter square or meter square, what we can say. Then if you cut this particular stuck into the 4 different things, you will get around 12 blocks, or half. If you get, you will get 12. 6 will be doubled into 12. Then if you again cut into again half, then you get 24. Then similarly, if you keep on cutting every particle size, see for example this particle size should become narrow, then you will be getting around 2.5 acres of surface within just 6 meter square box area. That means you can, every time you cut, the new surface is exposed. For example, if you cut here, the surface area, 2 extra faces will come. Instead of 6, you are having now 12 faces. That means in between 2 faces are extra, next 4 faces are extra. Like that we are having plenty. Okay, 2 to the power 3 or 2 to the power like that, 8 faces, and 2 to the power 4 like that. So until you get every particles, here it is 6 meters square now. So every particle is nano, then you can have around 2.5 acres of surface within 1 square meter. This thing. So here the values maybe in centimeters square, but it is meter square. So the width of a hair is around, now we know that what is nanometer. Now 1 nanometer is 1 billionth of meter, that means billion times lesser than 1 meter. So the width of the hair is around 100 million nanometers. That means the diameter of this thing. Now imagine how small it will be. That means it has to be less than that, less than almost 100 million times. So human blood cells are around 2000 to 5000 nanometer long. That also, the only blood we will see, but the cells we cannot see. The strand of DNA has a diameter of around 2.5 nanometer that we just saw in the beginning. A line of 10 hydrogen atoms in one is 1 nanometer. If you are keeping 10 different hydrogen atoms, you will get 1 nanometer. That means we are just comparing how this nano scale is so cool. Why nanoscale has become so important? That is very important to study. So there are 4 schools of the nanoscale. That's why it has become so important. The first thing is the quantum mechanical properties of electrons inside the matter are influenced by the variations on the nanoscale. That means, as I told you, since this falls under the atomic scale to the molecular scale, the quantum mechanics come into picture here. Here the particles behaves exactly like the quantum laws of quantum physics. So here a lot of quantum mechanics in the sense it's about wave-like particles or wave-like properties of electron inside the matter are influenced by variations on the nanoscale. Now the electrons in the nanoscale depends on wave nature rather than the particle nature. Understanding? What is the difference between classical physics and quantum physics? That we should understand first in order to understand this point. The classical physics is nothing but we consider the electron is having only one property, that is particle nature. That is called classical physics, and whatever the laws have been made that follows as this thing, that is called as old physics or classical physics or normal physics, what we say. When you say quantum physics, it's about the particle, the electron, which is having two properties, particle nature and as well as wave nature. So whatever the wave natures or dependency is there, that completely is explained by the quantum mechanics. Whereas quantum mechanics explains both particle and wave nature, whereas classical physics explains only about the particle nature. That's the difference. And at bulk, we don't see wave property much. Wave property of the electron is negligible. So we can simply apply the laws of physics. But at nanoscale or at atomic scale, we have to apply physics because wave nature of the electron plays a huge role there. Okay, but in bulk there is no much, negligible. But in nano, it is huge role. The particle nature will be negligible, but it is not so negligible as we have the negligible of the wave nature in the physics. So it might be confusing for you. To make you simple understanding in classical physics, imagine you are a person and when you go with your friend and in your family you are old physics or just a physics. That means in your family your parents see you as one of the innocent guy or one of the innocent son they have, right? But when you mingle with your friends, then only your true colors will come. Okay, you might be having some bad habits, you might be scolding people, you might be having some naughty nature that you don't express in home. So in home they have different opinion on you. That is, they see you as an innocent person. That means the classical physics see electron or a particle has got only one property, that is, electron has got only one property, that is particle nature. So that is in home you are a physics, but when you with your friends you are a quantum mechanics. Understanding? So in quantum, so your friends act as a quantum mechanics, your parents act as a physics, world physics. So world physics knows only one property of the electron, that is particle nature, and depending on that whatever it is there. So at nanoscale or at bulk scale only that property matters. So that's why in bulk normal physics still works good. But at atomic scale, if you go, you have to apply different physics, that is quantum mechanics, because you know that your friends know that you are not an innocent, you are a naughty person, you have bad habits, you do scold, you do all these bad things and all. So they know that. So quantum mechanics knows about the other property of the electron itself. I hope it's clear with the example. So the quantum mechanical, that is wave properties of the electron inside the matter or particles are influenced by the variations on the nanoscale. That means wave-like property is more effective in the nanoscale than the bulk. So by nanoscale design of the materials, it is possible to vary their micro and macroscopic properties such as charge capacity, magnetization, melting temperature without changing their chemical composition. That means by changing the sizes, we just saw that the nanoparticles are changing, so its optical properties are changing here, right? The size is changing, optical properties are changing. Similarly, the hardness also will change, mechanical properties change, electronic properties also change. So all these things properties are nothing but what? Charge capacity is electronic property, magnetization is a mechanical property or an electronic property, then melting temperature is also one of the physical property. All these things will change, but their chemical composition doesn't change. Here the gold is gold, right? Chemical composition is not changing. but their properties are changing, their melting temperature is changing. So this is one of the most important scope of the nanomaterials. That's why the nanoscale has become so important. That is, the reason is what? First reason is what? Since they follow the laws of quantum mechanics, as we change the properties, the scale from macro to the micro to the macro, from smaller to the larger nanoparticles, we can change their micro and macroscopic properties such as charge capacity, magnetization, melting temperature. Not only these, there are plenty of properties, optical properties, hardness, wear and tear properties, mechanical properties, okay, magnetic properties, electrochemical properties. All those things will be changing. That was about the mechanical quantum mechanics. Okay, so since they follow quantum mechanics, they have got the importance. Next, the key feature of biological entities is a systematic organization of matter on the nanoscale. So here what happens, the biological entities, what we are having naturally, the same set of the size we are having at nanoscale. So developments in nanoscience and nanotechnology would allow us to place a man-made nanoscale things inside our living cells. We know that our molecules, our whole body is made up of molecules, right? We are having the RBC, that is a molecule. We are having the blood, which contains RBC, WBC, platelets, all are molecules, all are molecular scale in nature. And hemoglobin is a protein, which is again comes under nanoscale. And DNA is a nanoscale, RNA is a nanoscale, everything is a nanoscale. So that we can keep some certain man-made things inside our body. For example, if I want to deliver a drug directly to the cancer tumor without causing any effect, I can have that. I can make nanoparticles, I can load the drug inside the nanoparticle, I can insert that into the femoral artery, and this particular nanoparticles will be loaded with attached with antibodies, specific antibodies. This will take to the particular tumor itself, because antigen antibody complex are very highly complex in nature and highly sensitive in nature, so that only antigen of the cancer cell will bind to the antibody of the cancer cell. So these antibody of the cancer cell, which is attached to the nanomaterials, which has got anti-cancer drug. So when you insert it in your femoral artery, which is there in the left and it makes its own way, because it finds its antigen inside our body. So where this cancer will be there only the anti-surface protein will be there, that is antigen. So this will go and bind only that cancer tumor, and then the antigen antibody complex will form. The drug or the nanomaterial will go inside the tumor, and then since inside the tumor the pH will be changing, the temperature will be high or pH will be high, so it will degrade itself, so that it will release the anti-cancer drug like doxorubicin, so that it can kill the tumor from inside, not from outside. So we can avoid because of the chemotherapy. We know that cancer patients, they suffer a lot, they die eventually because of organ failure, because of some tissue failure, because of some other diseases. All those things can be taken out, because nanotechnology has already proven well in the preclinical study, that is testing on animals. So now it is under clinical studies. In some studies, even clinical studies also phase 2, phase 3, they have completed successfully. So in future we can have these particular nanomaterial targeted drug delivery systems, where the drug can directly deliver into the tumor without causing any effect. So this certainly will be a powerful combination of the biology with material science. So that is very important. That is going to make a huge revolution in biomedical field. Understanding the first one is quantum mechanics. Because of that, changing the properties, we can have any property, whatever you want, you can manipulate it, you can tune our properties. Second thing is, with the help of biology, with the help of nanotechnology, we can combine biology with the material science and we can bring wonders. And the third thing is, nanocell components have very high surface to volume ratio. Because of that is what the best property we are having. High surface, less volume. So surface to volume is high, so ratio is high, so making them ideal for the use of the composite materials, reacting systems, drug delivery, chemical energy storage such as hydrogen and natural gases. For any application we need more surface, and nano has got that. So third one is what? Surface to volume ratio is high, so that's why the nanomaterials are so important. The last one, the macroscopic systems which are made up of nanostructures have much higher density than those which are made up of the microstructure. For example, I have this material which I have made it from the microscope structures. That means from normal, whatever the technique what we use, I use that only. I made this. Now, on the other hand, I have another material which is being reduced, all the raw materials which are in micro scale is reduced to the nano scale, and then I will make this. Now, out of these two products, this is made by the nano, this is made by the micro. The nano will have more strength, more hardness, more the durability, everything. It has reduced to the nanoscale, surface has become more, surface has developed issues more, its hardness is increased, its optical properties are increased, its conductive properties are increased, every properties are increased when you reduce to the nanoscale, and when you made the big material out of it, that will have more effect. And one more example I would like to give, I will take two bricks. So this is made up of the macro normal cement, and this is made up of the cement I take, I reduce it to the nanoscale, and then I will make this. So according to the science, so nanoscale, this will have more hardness. The reason is simple, because it is made up of nanoscale materials, and this is made up of microscale materials. So whichever the materials which are made up of the nanoscale materials, they will have more better properties. So they can also be better conductors of electricity. This can result in new electronic devices concepts, smaller and faster circuits, more sophisticated functions, and greatly reduce power consumption simultaneously by controlling nanostructure interactions and complexity. All these properties we can gain. The first is quantum mechanics because of the size, and we can tune any properties whatever we want. Second thing is the key feature where the nanotechnology brings the biology and the material science together, and it can bring wonders, and it can solve a lot of problems which are associated with the biomedical field. And third thing is surface to value ratio is high. Because of that, we can use it for wherever the activity is more required. Next, the last one is whatever you prepare from the nanoscale will have greater impact than the which will be prepared from the microscale particles. So next topic is frontiers of the future and overview. All these things comes under that only. You can write all those things in this thing only, but separately I will explain you as a separate topic that whatever it is. Okay, so in this subject, whatever you are studying as a nanotechnology student, as a first year student, you don't have to write all these things, whatever I just explained about things, 3 to 4 videos, but trust me, you can explain any one topic for 5 marks. Okay, anything you can see, whatever is favorite, you just see. Okay, so let's see in the next class with a different topic will come. Okay, all the best.